Comparing the quality of two cars, a sport BMW and a Kia. In these two pictures, the two cars are moving at the same speed, which is 100 kilometers per hour. But which one is usually faster than the other, or more preferred or more preferable by the guys especially? It's actually the sport BMW, because the sport BMW can accelerate, can increase the speed at higher accelerations. It can speed up in less time. That's why it's more preferable by the guys. However, a Kia is actually cannot really speed up at high rates. That's why usually girls choose to drive Kia cars. So now, what is acceleration? What is speeding up and speeding down? Consider the following cases. If you are given that the car is going at 100 kilometers per hour, what does this represent or describe? This describes the speed because it's only telling how fast the car is going. It's only telling how much distance or how much ground is being covered per unit time. Now, what about if you were given that the car is going at 100 kilometers per hour east? This means that you are given the velocity. This is the velocity because it's telling the speed and the direction the car is going in. Now, what about the car slowed down? Given that the car slowed down at the stop sign, then it sped up. So it slowed down, then it sped up. What does this mean? This means that it changed its speed. So this is the acceleration, not the speed, not the velocity. This is the acceleration. This is the acceleration because it says the car changes its speed. Its speed when it slows down, it decreases its speed. When it speeds up, it increases its speed. So this is about acceleration. Now, how can we define acceleration? Acceleration is the change of velocity of a moving particle with respect to time. It's how much does the velocity change with respect to time. Now, for grade 10, we define acceleration as the change of the speed with respect to time because we only study the case of one-dimensional motion and one-directional motion. So there's no change in the direction. That's why we define it as change of speed. So in general, it's a vector quantity. Its unit is in meter per second squared. It's SI unit. And there are different types of accelerations. Could be uniform, could be non-uniform, could be acceleration, could be deceleration. Now, as a formula, the average acceleration is represented by the vector A average vector equal delta V vector over delta T, which is V2 vector minus V1 vector over T2 minus T1. So vector quantity must be equal to vector quantity. Considering the general case, the average average acceleration vector is equivalent to the difference in the velocity, which is a vector quantity over delta T. But for grade 10 here, because one-dimensional and one-directional motion, we're going to consider only A average as a magnitude, which is equivalent to also a scalar quantity, which is the variation of the speed with respect to time. So now the instantaneous acceleration. The instantaneous acceleration is the average acceleration for small time interval, that is when delta t tends to 0. So as we had average speed and instantaneous speed, in which the average speed considered a large period of time or a long period of time or the whole motion, while the instantaneous speed describes the speed at a certain specific instant. Similarly, here we have the average acceleration and the instantaneous acceleration. The average acceleration is like for the whole motion or for a long period of time. So how much did the speed change with respect to time? How much did it increase or how much did it decrease? However, the instantaneous acceleration actually it's for an instant, and mathematically we express it as delta t tending to 0. this means that when we write any parameter tending to 0, this means it's not equal to 0, but it's very, 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 very small to compare to the scale considered in the situation. So the instantaneous acceleration is represented by the vector a vector equal a I vector. If the speed increases, then it's going to be positive I. If the speed decreases, then it's going to be negative I.